Good afternoon and welcome back to CSC 353 Systems Security. We were reviewing on Monday the important role of um, ensuring that services, in particular DNS, that you had more than one resource for DNS in the mix. And one of the ways to do this is to implement something called network load balancing, or NLB. You can have multiple DNS servers, and you can control those DNS servers so that when your internet service provider has a problem with their naming service, we depend on naming services for everything we do online. So online messaging apps, email, social networks and social media, um, anything that we do on the web-based access, we use names. And so it's kind of an Achilles heel. And we showed you how quick and easy it was to establish a DNS server on a virtual machine. And essentially, I was in the process of demonstrating how you could be sure that I'm using my own DNS server as quickly as it took. How many minutes did it take on Monday afternoon for me to set up the role and get it started? How many minutes, roughly? 10 minutes or less, right? 10 minutes or less. So that's not all we can do with DNS, though. DNS allows us to have more control over our named resources in our network. And there are two very effective ways to make sure that you are in control of what happens to the devices and systems on your local network when they're connecting to named resources, especially the named resources for your own organization. But what I have running now is a server named Lilu. And what I neglected to do when I was demonstrating how my laptop, my host, is using this machine on my network, I forgot to do something called clear the cache. So I'm going to clear the cache on the web server. I actually stopped the service, but I didn't clear the cache. What happens when you ask for a named resource on a network is that it first checks the host's file on your local machine. Then it checks the DNS cache. Then if it doesn't find it there, it goes to the nearest DNS server and checks the DNS cache on the DNS server. If that entry isn't in there, in the DNS server cache, then the DNS server starts the naming resolution where it goes out to the dot, the root domain, and then the .com domain, and then the, such and, Google domain. And so all that back and forth is what takes so long for DNS. All along the way, hackers have a chance to commandeer your machine. And what I want to do is show you how easy it is to hard code or hardwire your local references for resources on your networks with a couple of extra steps. So name resolution on the internet is one thing that DNS servers do. But DNS servers can also store their own records. And when other clients are asking, if you created your own domain, if you created your very own domain, and I think we're going to do that right here and right now. In my local network, I'm going to create my own domain because I want my own, I want to be able to refer to and access all of the connected resources in my home network by name. So what I'd like to do is ask somebody to help me come up with a real jazzy domain name. Can anyone give me a jazzy domain name?
How about Red Velvet?
Red Velvet. Do you want it to be redvelvet.com or redvelvet.net or redvelvet.org?
Velvet.com.
Redvelvet.com. Okay. Now, what I'm going to do is show you that I've installed the internet service role on my host machine. So I have a host virtual machine. No, I'm sorry. I have a server virtual machine. And you can have a server virtual machine too. You can download the server software. In fact, have we done that yet? Have we started that process yet? No, we haven't. You have secured your own system, is that correct? Module one?
Yes.
Okay. Does anybody read their email?
Yes.
Yes.
And did you read the whole email?
I read the article.
Uh-huh.
Same.
Did you read the email about what would happen if the first student brought up in class, what? Do you remember?
Nope. I skipped over that part.
I think I remember. Yeah.
Uh-huh. I said, the person who reminds me first of this matter as class begins today and shares an answer will receive additional credit. So what was I doing? Well, I was talking long and I was kind of hoping somebody would go, oh, that's right. I read that article and see, the question was, Wired just carried an article about a serious Apple flaw. See the link below. Which component of our current module is exposed in this case? Hardware, software, or services? The whole focus of this module is how do we secure or harden? How do we lock down hardware, software, and services? So if we look at this article, it says security researchers found a class of flaws that, if exploited, would allow an attacker to access people's messages, photos, and call history. So we have a case where personal data is being accessed. Is the flaw they're talking about a flaw in the hardware, a flaw in software, or a flaw in services? And I'll give you a hint. Services are running apps in an operating system. So when you see services, what you're really talking about are, okay, that's operating system applications that are running constantly, right? That's what that means. Services, hardware, software, and services. Now we're going to take a whole module later in the course to focus on the operating system as a whole. But when you have a host that's running services, now it has resources that can be used by others. So I'd just like to ask anyone here, what was your impression of this article and which do you suppose this article focuses on? Is it hardware? Is it an application flaw? Or is it something that has to do with services that are embedded and running in the operating system?
Yeah, I will say the services.
Same.
And how did you get to that conclusion?
I feel like with the phone calls and things like that, that's an operating system. And being that they could have access to all of that, then it would indicate yeah, a hacking towards the services.
Yes, that's a good instinct. And the title is a clue itself, right? So the bug has to do with the iOS or Mac OS. They're talking about OS X, right? So the Mac OS is called OS X, and portable devices use iOS. So it's definitely a services interest, and it's serious, right? It's serious. Now, one of the Achilles heels of services is that they advertise their resources using DNS. So I keep hammering DNS. It's like nobody really realizes how critical DNS is and how all of these cool hacks that have created huge exposures started somewhere with a redirection. And I'll show you how this works. On my server, I loaded two roles, DNS, that's what you learned the last class, because I want to run DNS on the local environment I'm using to demonstrate in this class. But then I also loaded IIS. This is the Microsoft website application. It's a server role. So I added the IIS role, and that turned my Microsoft server into a website. And if I open a browser here, and I open the browser and I point to myself by my IP address, if I put in 192.168.1.6, then what you see is the splash screen for the website that's running on my server. Okay, everybody with me?
Yes.
Yes.
Now, let's pretend that you knew you had a named resource that was really important, but you were depending on your internet service provider for its DNS. And let's say that your network resource stored all of your commercial accounts, all of your customer payment instruments, their credit card numbers, all of that stuff, right? Is everybody with me?
Yeah, yeah.
Okay, so it's really important. And what's more important is that it's on your network, okay? But you depend on your internet service provider's DNS to tell all your customers, oh, here's their website. So the website is something you control, it's on your machine, and yet you depend on who? Your internet service provider to tell them all your stuff, right? Well, what happens if their website dies? And how can you be sure that people will always be able to find it? This is where advertising comes in. You create a forward lookup zone. This is the DNS record that others can use to find your resources. But just to make a point about how powerful it is, if you control your own DNS, you can control where someone goes. Hackers want to tackle DNS. They want to tear apart DNS. You remember the diagram I showed you of round robin where the DNS requests hit one server and then the other server and the other server, right? Well, that was resolution. But then if you have multiple copies of a DNS, all the domains, right? So named resources are organized into something called domains. And you've heard of these. What's the domain name of Google? Google.com. What's the domain name of Facebook? Facebook.com. It's a .com domain. That's called the first level or primary domain level. It's a .com, right? Or so the important thing is that understanding DNS, we could have a whole course on DNS. We could have a special topic on DNS alone, and it would do wonders for everybody in the territory in terms of securing our networks. But the thing I want you to understand is that top level domains, right, like Google and Facebook, those records need to be stored somewhere on a single server we call the primary. It's the read and write copy of the domain name. And so what you're doing is wherever that DNS record is stored for that company, that's precious real estate, okay? And what you have to do to keep a lot of multiple copies in circulation is write protect them. You write protect them, and then you expose the write protected copies of your domain name, okay? Can you hold a second?
Sure.
Okay. So if the key to this is to have the read and write copy, the primary copy, which is called the primary zone, that's owned by Google or by Facebook. But the secondary copies are write protected. They cannot be changed. So they're read-only copies. And those are the ones that you keep multiple copies of. And you set up this round robin so that there's load balancing on the network. So we have Google everywhere. And if I ping Google, what's going to happen here is that I see Google, but the truth is Google has data centers all over the planet. Google is so big, they have data centers in Puerto Rico, in Florida, up and down the island chain, right? And the simple truth is this address for google.com is probably not the headquarters in Silicon Valley. There are multiple copies. The important thing to understand is that there are multiple copies of resources all over the place. And that's part of staying stable and secure so that your system doesn't crash. But the bigger part is having control over that malleable, writable copy, the primary. And in your own environment, you can hard code things to direct the traffic the way you want. Now, hackers want to do this intentionally to redirect the traffic. I want to show you how that works. Okay, so I'm going to create a forward lookup zone here. I'm going to add a zone in this DNS server, and I'm going to make it a primary zone because I'm creating a whole new version of this. And what was the name of it was redvelvet.com?
Yeah.
Okay. So I'm gonna create a zone name called google.com. And it's going to create the primary zone that I can change. And I'm going to say I don't want others to change it. And then I'm going to click finish. But I'm not finished there. I'm going to create the next new zone. And I'm going to call it, and I'm going to make it a primary zone. And it's going to be the red velvet, VELVET.com, right? Redvelvet.com. What a coincidence. I'll be eating red velvet cake later today.
Must
So
be nice.
yeah, we're helping someone celebrate their birthday. So it says do not allow dynamic updates. That means I don't want to allow hackers to change this. But the truth is hackers are very gifted at going in and changing things, right? If I'm not careful about protecting it. So I take google.com and I'm going to create a record, a host record, so that I can find a website for redvelvet.com. Now I'm going to pretend that the website I just showed you, the splash page, on this same machine is the Red Velvet website. Is everybody with me?
Yeah.
Yes.
So I'm going to create a new host record, and I'm going to call it frosting. Okay.
Yeah.
And the domain name is redvelvet.com. And together, the host name, frosting, And the domain name, redvelvet.com, that's the fully qualified domain name. The other, you hear reference to that, it's called FQDN, right? And you notice when I did that, it put a dot at the end of the com because the dot is considered the root of the internet itself. Everything on the internet that uses DNS and naming, domain naming system, ultimately that is the very beginning of the DNS system worldwide, the dot. But if you have your own internal DNS system, that's true too. So I'm going to put in the IP address of this server, and I'm going to create an associated pointer record. Now, that's going to misfire because I don't have a reverse lookup zone in here. I'm going to cancel this for just a second and create a reverse lookup zone for the network address range I'm operating in. That's really important. It's also a primary zone, but it works in reverse or backwards. It converts a number to a name. So DNS converts a name to a number, but if somebody has a number, they can get a name back. Does that make sense?
Yeah.
So I'm going to do 192.168.1, and I'm going to create a reverse lookup zone. And I'm going to say, okay, and finish. And now I'm going to go back into Red Velvet and I'm going to finish my host record, okay? And I'm going to put frosting. And then there's redvelvet.com. And I'm going to put the IP address hard-coded in here. When I say hard-coded, I mean I'm going to create a static record, an unchanging record. I'm going to add the host. It's going to say, okay, it's there. And then I'm also going to create an alias. So I'm going to create an alias. It's called a CNAME, right? It's kind of like a copy name, same as, or also known as, AKA. And I'm going to use www. Does that make sense?
Yes.
www. So I'm going to use www. I'm going to go browse into Lilu and look up the forward. And there's Red Velvet and there's frosting. So when I want to get to the web browser for redvelvet.com, I don't want to have to advertise that it's the frosting host where Red Velvet website is. I just know that everybody else in the world knows www dot. So I'm gonna use this alias, also known as, right? Now, I'm also going to show you what hackers do when they can get into this copy and they can corrupt the copy, which is another reason why you protect the primary DNS server and you only advertise your DNS records with read-only secondaries, right? Using round robin. So they can't be overwhelmed. They can't be shut down. There's too many of them running. They keep passing the requests from one to the other. You can't keep up with all the different DNS servers there are. And to make matters worse, when you get on there, you can't even change the records because they're write protected. Does everybody follow me?
Yeah.
Yeah. But let me show you what happens when a hacker, just one hacker, hits pay dirt. I'm going to create another zone record. I'm going to create a host called gotcha.google.com. And I'm going to make this 192.168.1.6. It's also going to create a pointer record. Now I'm going to create a alias, same alias, www. Okay, everybody with me?
Yes.
So here you go. The last thing I'm going to do is I'm going to restart the service. Now that's what I didn't do. At the very end of the class, I was going to show you, oh, look, you know, my laptop is using my server for DNS. And I was going to show you how I couldn't hit Google because my DNS wasn't running. I stopped the service, but I didn't clear the cache. You always want to clear the cache, but then you want to remove any previous requests. If the records aren't set up and you get a previous request for Red Velvet, it's going to say Red Velvet doesn't live here. that's still sitting in the memory of the running service, which means that when you finally create the record and say, okay, everybody can find Red Velvet, they can't because you didn't clear it. But then I want to restart the service. That's the other thing that I didn't do. You want to clear the cache and restart the service. Everybody with me? Now, what am I going to do next? I'm going to go to my host. And in my host, I'm going to duplicate what I did before. I am going to clear my browser cache, clear all the data. And then I'm going to close my browser. I'm also going to do this on my other browser. I'm going to clear my browsing data. Close this, close this, close this. Here's what I'm clearing. I'm going to clear everything. Okay. And why did I do that? I want everything to disappear for a time. Okay. And what I want to do next is I want to clear the cache on my local machine after I make the change to my network configuration. So I'm going to go into my control panel, and I want to tell my Wi-Fi adapter in here that I'm going to use my server for DNS. Everybody with me? I'm going to use this server for DNS, okay? Now, of course, I'm using my server for multiple purposes. It's also running DNS in addition to the website, okay? But I want this machine, to use my virtual machine for DNS. I don't want it to use my internet service provider's DNS, okay? And I just cleared the cache, all right? And I'm going to clear the cache on my machine. So there's cache on the server and there's cache on the local machine. If I've been to Google already, well, it knows where it is. And it's stored in memory. And if I wanted to create a fake Google, I got to take that stored temporary cache out of there. So I'm going to issue the command ipconfig flush DNS. And now I've done it. So what I'm doing next is I'm going to see if I'm actually using my web serving DNS machine, my virtual machine. I want to see if it's the DNS server I've configured on my wireless card. So I'm going to do ipconfig/all. And does everybody see this right here? I'm not going to my wireless router at 1.1, which relays it out to my internet service provider, which relays it to somebody else out on the internet. I'm using my own DNS server. Okay? Everybody with me? Watch what happens. What do you think if I ping Google now? What am I going to get? Hello? Can somebody unmute their mic? Do we have?
Yeah.
Okay, you're with me then. All right.
Yes.
I made those changes so that DNS is pointing to my own machine, and I set up a fake Google server. So do you think I'm going to get the same address I had up here? Or a different address? I just cleared out all the cache.
A different one?
A different one. It's struggling. It's thinking. It's not sure what to do. said ping couldn't find google.com, right? Let's open up a web browser and see if the web browser can find www.google.com. Now, Edge has built-in security so that it takes any request I have and it sends it first to Microsoft. So Edge might not, this might not work. But if I go to www. What was it? Red Velvet? Where is it getting that information now? Oh, it says it can't reach my machine. Hang on a sec. 192.168.1.8. Okay. Something happened to my server. I was demonstrating this to show you. And let me see if I can get out. Okay. So Bing goes out to Microsoft first because it's Microsoft's web browser, and it takes that request and passes it out. Let me do this. I cleared the cache and I restarted the service. Yeah, I wonder if they've done some things to change the way this works. Oh, I'm going to clear the cache here on the server. And now let's try this again. I'm going to open up a browser and I'm going to ping frosting.redvelvet.com. Well, it's actually going out to the real internet, trying to find frosting.redvelvet.com, and there is a server that's named that. I have a question for Raheem. Did you know that Red Velvet was an actual domain out on the internet when you suggested it? I mean, you may not have. I'm just asking a question. Raheem, are you there? Okay, so yeah, I think what we're seeing is we're trying to do a test with a notional domain name, and it actually exists out on the public network. So we'll find another way to demonstrate this. In any case, yeah, I wonder if my network IP address changed. If my network IP address changed, that would prevent everything from working. And that would jam up my demo. So one thing you want to do with a DNS server is make sure that it's assigned to a static address, not an automatically assigned network address that can change, right? Because if it changes, did I say .6 or .8? I think it's .6. You know what? I got the wrong IP address. That's why this
I
isn't.
think you put .8.
I put .8, didn't I? That's why this isn't working, okay? So here's what I'm gonna do. I'm gonna go to the A record here. That says .6, right? Oh, okay. So in the host client, that's correct. That's .6. And this is ready to go. It's waiting on standby to give me the right redirection to this new website. The problem is that in here on my own network connection, I put in .8, I think. right in here on my Wi-Fi. Ah, that's it. That's the problem. So I'm going to use my, okay, my apologies. But that just goes to show you that usually it's something simple. So I'm going to point my host, my laptop, to my virtual machine that's running DNS. And I don't think that what's happened is a bad thing, because what you've just witnessed is how we walk through troubleshooting this. Okay, where do we have the problem, and where is this jammed up? And if I have the name right and I have the server set up right, then there's usually a client setting. So that's another thing that is really important to stress. Service security begins with DHCP. Why DHCP? My laptop receives a automatically assigned DNS server, and I can set that up once in my DHCP system so that everybody uses .6, not my internet service provider. Put another way, if I get those details correct, then when I put them in DHCP, in a sense, that service produces more redundant entries. And every time you reset your network switch, it gets a fresh copy. So if a hacker knocks you off and is pointing to their DNS to try to misdirect you, the DHCP says, no, you're on .6. No, you're on .6. And in companies with more than a dozen people, it's not a bad idea to have 2 DHCP servers, 2 DNS servers. So that way, if one's down, everybody isn't sitting there scratching their head going, what happened to the internet? Okay, so I'm going into here, and I went into here, and I went into here, and I made this change. But I told you earlier that my DNS cache stores errors as well. So if I try to go to Google and it was looking to 192.168.1.8 beforehand, I have to clear that out. So I have to go to the cache on my host on my laptop, and I'm going to pull up the flush DNS because I want to get that out of there. And now if I try to ping, frosting.redvelvet.com, oh, look, it's the local address. What if I try to ping Google? Okay. All right, so there's something intuitive about that isn't working right. Oh, wait, there's this hosts file I can modify, and the hosts file on my Windows system overrides all the DNS. So the ultimate redundancy is the hosts file. Watch what happens next. I'm going to flush that error. It couldn't find Google, right? I'm going to flush that out of there. But I'm going to go in my system, and I'm going to use Notepad, but I'm going to open it and run it as an administrator. And I'm going to look for a special file called hosts, not hosts.txt, but hosts. I'm going to open this, and I have to go to the Windows directory on my C drive inside the System32 subdirectory, inside the drivers subdirectory, inside Etsy, and I have to change this option so that it's not just looking at .txt files, but it's looking at all files. I open hosts, and now what I'm going to do, I was demonstrating this in another class. I'm going to take this and I'm going to put in 192.168.1.6, and I'm going to put google.com. I'm going to save this. Then I'm going to go back to here. No, I'm sorry. I'll go back to my browser. Yeah, this is my browser. And I might need to clear the cache because I got a negative result and I don't want it to pull another negative result. So I'm going to clear the cache. So let's just open that up fresh. I'm also going to do the same for Chrome because, oh, look, it's trying to go to Google by default and it's having a hard time. It's having a hard time. Privacy and security. We're getting there. We're getting there. I'm going to clear the data in this too. Close this, close that. So I've cleared the cache on the system with the ipconfig flush DNS. I've also cleared the cache in the browsers. I've resolved the problem between the DNS where I'm pointing. And for ultimate redundancy, I want my local machines to go to something else besides Google. So I have multiple layers of DNS service and named resources, first with the hosts, that's referenced first, then the DNS server I set up, and now I'm pointing all my machines to that stuff. So let's watch what happens now when I open up Chrome. I'm going to go to www.redvelvet.com. And what I should get is my splash page. So now that's hitting my system, my server, okay, the website. If I go to HTTP, and I'm not trying to go to Google, the secure site, I just go to the standard site. I'm not using S there. I'm not using HTTPS, right? Does everybody understand what I'm talking about?
Yes.
The S means secure. The S means there's a padlock. The S means there's a certificate that encrypts the traffic between the websites. I'm going to use this. And I'm going to use www.google.com. Oh, oh my gosh, what happened? Now, did you know I can go to Google? I can view the page source. I can copy it into my web server and it looks just like Google. So now I can set up my Google server by copying the web page source on the real Google server. I can copy it into my web server. And then my local machines can think what? They're on Google. But they're not. They're not on Google. They're on my machine. And when they're typing stuff into those windows, their personal information, guess who's capturing all of that? I am. So what you've seen along the way today is what happens if you don't have the right DNS service, if you don't have it locally, if you don't have redundancy, if you don't have fallbacks like the hosts file, right? So you have the host file. If you have local resources that you want your users to be able to find even when DNS isn't working, even when the DNS server at your place, at your internet service provider, at Google, at Cloudflare, at all these, if DNS is disabled, you can still find your resources if you have an entry in the hosts file. That's redundancy for a service. Now, the ultimate redundancy for a service is something called clustering, okay? So when we talk about clustering, we're talking about something that's a little different than a running service on a server. DNS has the same copy of records for all of the different servers that are providing DNS. So when you, anywhere in the world, want to go to google.com or you want to go to facebook.com, all of the records for facebook.com is on that primary server, and every time they change it, it's replicated to all of the secondary servers. And then all of those teams of servers share the same records over and over and over again. That's called network load balancing. When the data is the same and it's just repeated. If I had five websites and it was all the same data. Oh, it's trying to go to HTTPS. So I guess I need to put in frosting or www, and I put in this, and then www.redvelvet. I hope I'm spelling it correctly. No, yeah, all right, so that's kind of funky. In any case, where was I going with this? The records in a DNS server, there's a small amount of data and it doesn't change. But what happens, and let's say you have a website, okay? So I'm gonna open this up and I'm gonna point it to myself, 192.168.1.6. All right, so let's pretend that my website, I have multiple web servers. And on my website, I'm simply sharing the same content over and over and over again. I put stuff out there. It's not interactive, meaning the people who visit my website are not putting information into it and they're getting interactive information out of it. If all I'm doing is providing information, I can do network load balancing with web servers just like I do with DNS. But what happens if I have an email server or a database server, or I have a server like the one that runs Amazon, or a server like the one that runs Facebook? These are large databases, the one that runs Google. The information on those systems changes all the time. And those servers have to replicate their changes. They have to replicate their changes constantly, and that's called a clustered server, okay? So when servers, clustered services, and I've done it. I've gone ahead and put my own, yeah, I did that. So my DNS is jamming this up. I was gonna go to Google and search something and my DNS isn't working because the real Google is in the wrong DNS server. What you're seeing is what happens when a few records are changed. People can't get their job done. What I was going to show you is a picture of what a clustered service looks like. And we will take that up as a special topic when we review the rest of the content in Module 2 on Friday. And we'll review the solution for our Module 2 and the steps and tasks that you follow to complete the solution in Module 2 on Friday. Are there any questions before we clear our session?
No.
Okay. So what you've had a chance to witness is what happens now that I've changed my DNS. I'm not really pointing at Google anymore in my server, am I? I'm not pointing to Google really when my DNS server has this listing, it's wrong. And then on my laptop, while I'm trying to go to Google to show you something right now, it's broken now, right?
Yeah.
Yeah. Now, if I first copied all the source code from Google and set it up on my website, on my server, right? And I loaded the Google web page in here, then I could trick people into entering information into that prompt. Like I could have a password screen for a bank and people put in their passwords, right? And
Yeah.
it looks like the Banco Popular website, or it looks like Amazon, where I'm buying something and I'm putting my payment information in. But what's happening is that that website is capturing that, and out the back end, it's sending it out to Amazon. So you get your Amazon order. What you don't get is security of your own financial information. That's what's called a man-in-the-middle attack. We set up a website in between. We copy that stuff from the real website, and then we muck up the DNS, which is why we have to have multiples of that. So we'll cover a clustered server on Friday, and we'll also cover the rest of the material for Module 2.
Okay.
Thanks for joining us, and we'll see you Friday.
All right. Thank you.
Bye-bye for now.